Hi, welcome back to Sensible Project Manager Hangout. This is Hangout. No, this is Hangout number 37. I've had to restart the Hangout, so essentially going to be able to delete the previous recording. I thought I was having some technical difficulties. Hopefully, this will work better. So welcome back. Again, this is Sensible Project Manager Hangout number 37. My name is Mark Philippi, and today we're going to talk about project estimation. And in this comes from a presentation that I gave to several project managers here locally where I'm at just earlier this week. And I thought it was good content that would be helpful. Some techniques that we'll talk about how do you apply project estimates, how do you improve those, how do you take those and improve those in your project plan. So because we had some technical difficulties, I'm going to step right into this. Let's see if I can get this thing going. I have a presentation, as I said, I'll share. Let me share my screen. And here we go. Okay, so as I said, we'll talk about how to help your team improve task estimation. To start with, you can take the easy route. This is one of my favorite project management. My favorite project management, I guess, cartoons from Dilbert. It says, in a perfect world, the project would take 8 months. And so he's got a schedule of 8 months. But based on the past project in this company, I applied a 1.5 incompetence multiplier. So that's going to end up to be 12 months. And then I applied the LWF of 6.3. What's an LWF? Lying weasel factor. So I know the reason why I like this is because it seems like that's sometimes the way that we as project managers have to apply, not that we're calling the people that are on our team lying weasels, but we do have to apply um, some kind of factors quite often to those estimates that we get just because of history. We'll talk a little bit more about that. So today we're going to talk a little bit about why it's important to be predictable, why our projects should be predictable. That's really important as we deliver projects, to be able to become very predictable on how we deliver our projects, meaning when we are saying that we're going to deliver at a certain time and a certain budget and the scope that has been asked for, we should always be working towards making sure we're predictable on how we do that, so that the unpredictability in my past, that type of unpredictability in a project really becomes very upsetting for management. So we're going to also talk a little bit about how to improve those for your teams. Just as a kind of a level set, this discussion is going to align with project time management knowledge area and the project cost management knowledge area and the planning process group for that in the PMI definition in PMBOK. So if you're keeping track of how this aligns in that's where it aligns in the PMBOK. We're going to talk about the importance of estimating and its predictability, as I said, what obstacles we might have as we do estimating, some estimating techniques, and then how to apply those in a project plan. So for those of you that are familiar with the Big Dig, and those of you who haven't, let me describe what it is. The Big Dig is a project that occurred in the 90s and the early 2000s to basically change the way traffic was routed in the city of Boston, Massachusetts, in the United States. So on the left here you see a picture of a the freeway system that went through the heart of Boston. And this freeway was built in 1957, I think, is when it was completed. And essentially, if you look at it, it it really cut the city in half. A lot of people didn't like the way it really divided the city in half and caused some problems. So the project was the idea that they would take and put the travel underneath in a tunnel underneath the city in a, I think it was a 7.5 mile corridor to bypass the heart of the downtown city and replace that with some parks and so forth. And so you see the before and the after picture. The idea was pretty, the project to implement this was a very ambitious project and a very big one. So just to share a little bit of some of the details that I've been able to drum up about this project. They created during this project 161 lane miles in a 7.5 mile corridor. So they added 161 miles of lanes during this project. Just again, just trying to give you a picture of how big this project was. It to complete this project, they removed 16 million cubic yards of dirt. And if to give you a perspective on that, 16 million cubic yards of dirt would fill up 16 football or soccer stadiums to the top. Now that's a lot of dirt that they removed. To do that, they took 541,000 truckloads of dirt out of there. Again, that's a lot of dirt. 3.8 million cubic yards of concrete. Now, to give some perspective of that, if you were to create a sidewalk that was, I believe it was 8 feet across, 4 inches thick, you could build a sidewalk from Boston, Massachusetts to San Francisco and back 3 times. So that's essentially, for those of you that do not understand that distance, the distance between those is those 2 cities. I didn't look it up specifically, but it's roughly 3,000 miles to get across the United States. That means that you could build that sidewalk for 9,000 miles. That's a lot of concrete. This project created one of the largest highway tunnel ventilation systems in the world. So they essentially they have to move air in the tunnel to be able to keep the air fresh. And so when they did that, they had to create one of the largest highway ventilation systems to be able to move that air. They created the widest cable-stayed bridge in the world. I believe that the bridge that they created is 8 lanes across, which is a very wide bridge. For the utilities, they had to relocate 29 miles of utilities. So a mixture of gas, electric, telephone, sewer, water, and other utilities. They had to remove those and replace those and relocate those. That in itself is an incredible feat. 5,000 miles of fiber optic cable was installed during this. There was 200,000 miles of copper telephone cable that was installed. About 150 cranes were used on the project. And during the peak of the activity, 5,000 construction workers were on the project. Now think about that. That's a lot of people that are working. Now to turn this to those kind of statistics to more project-related ones. It took 5 years to complete the first 25% of the construction project. The second 25% was 2 years. So it took 7 years to get to the halfway mark. During the peak of the construction, there was $3 million that it cost each day. That's a lot of money that they were burning through. They planned to finish it in 1998. And here's some interesting, shocking things. Um, they actually finished it in 2007. So this project was delivered 9 years late. Now here's the catcher. The initial budget was $2.8 billion. The actual cost is anywhere from 15 to $22 billion. The $22 billion is if you account for interest on that $15 billion, the total cost would be about $22 billion. So I don't know about you. The reason why I wanted to point this project out is it's an example of a project that really grew bigger than it was anticipated. And if we think about that and apply that towards um, estimation, if I wonder, I really wonder if there were a better job of estimating the effort for this work, if they knew that it was going to be 15 to $22 billion worth of work, would they have changed, well, would they have even canceled the project, or would they have changed some of the scope of the project? I would guess that that would be the case because this project was overrun by quite a bit. Now, that again is just to help point out the fact that estimating is really important. And if you don't get it right, you can be like that big dig. Now, let's talk about the obstacles that we might have when we are creating estimates. As I think about it, there are a lot of different obstacles that you might have. There are obstacles that there might be resources that are changing throughout the project. So if you are creating an estimate for a resource that, if we're talking about work, if you're talking about the individual that might be working on a project that you have, and that project resource gets changed throughout, what the expertise of that resource might change the outcome of the actual work that's required. In my industry, most of the time I work with software, and sometimes software is a little bit ambiguous. Sometimes we just don't understand some of the new technologies. That's an obstacle. If a lot of times people will do estimation with by getting an expert, and they identify what the effort is. If you sometimes that expert does not know exactly what resources are going to be doing the work, so they might be applying an estimate assuming that a certain level of expertise is available to do that work, but a different resource is assigned. So for instance, if the expert that provides that estimate assumes that there's going to be a senior person that's going to be doing the effort, a task might be estimated at 50 hours to complete the task. And if I bring a junior person in there, it might take twice that much. Now that might be offset, that the cost might be offset because a junior individual is going to likely be less expensive than a senior resource, but still there is a disparity there. A lot of times, as I said, when a lead or somebody that is an expert is providing that estimate, you really are not able to work those estimates through those individuals. Some people are better at doing estimates. That's an obstacle that I've seen before. If you get to know your team, you might be able to understand which estimates, which individual provides a better estimate than other. If I understand if somebody's estimates are more optimistic than others, then I might add some additional as the Dilbert cartoon showed, the lying weasel factor on there. Not that they are trying to do that, but they just might be a little bit optimistic, so you add a factor in there. So there's a lot of different obstacles that you might have. I'm going to categorize them into there are two major obstacles that I think need to be understood or thought through. There's the concept of known unknowns when you're doing any project. The known unknowns are those things that you know that these things might happen. Things like new technologies that we know that we're going to be doing this project using this new technology. There might be some challenges in that new technology. That would be a good example of a new unknown. You need to be able to account for that when you're coming up with your estimates. And you just don't know how big of a problem that is, but you know that it is a problem. You know that you might have a resource that becomes unavailable. You know that that there might be some issues with weather if you're doing a construction project. Those kinds of things you can account for. Usually those known unknowns can be translated or identified as risks. So if you identify your risks, if you're doing a good job on your risk management, you can identify those risks and then apply a value to those risks, and they can be applied. Then there's this thing called the unknown unknowns. These are things that you can't even fathom might happen during a project. However, things do pop up on a project that you wouldn't even have thought of that might happen. And I think I've shared this example before, but this is a perfect example of an unknown unknown. On a project actually this wasn't one that I was doing, but I worked for a utility. We had an incident where there was a windstorm that came up. A neighbor's a neighbor's trampoline was blown into a a power line, and it took out the power that supplied the power to the data center of our utility, and the data center went down. That's an unknown unknown. Who would have thought that a trampoline would come and take out the power of the data center? That is an example of an unknown. So those are two major obstacles that I can think of. Now let's talk about, there's a lot of different estimating methods. I wanted to talk about these 5 different. First of all, top-down estimating. If you think about top-down estimating, this is usually used, and it actually could be used, these other different ones might be used as well as top-down and also bottom-up. But top-down estimation is usually used when early in a project, when you're beginning to fathom what you might be doing. You usually have to give some kind of estimate on what the project might be like, what the project cost and efforts might be, usually done at a high level, and based on either the scope or the deliverables. Bottom-up estimating, this method, is usually after you go through the details of detailing out the tasks from a lower level, after you've created your WBS, it's creating the estimates based on those details and accumulating all of those details into one total estimate. That is a bottom up estimating. Analogous estimating is the type of a technique that you would use if you are using this to compare your project with a project that was from previous projects. So if I have a project that is very similar to a previous project, you can look at the historical data of that similar project and roughly estimate what the costs and efforts might be on this new project. Parametric estimating is very similar, but it's A good example I can think of, if I have a project that I'm going to build a fence, and I know the cost of what it's going to take to build 100 feet of fence, but I'm going to have to build 1,000 feet of fence. I can just take that cost to build 100 feet of fence, multiply that by 10, and I will be able to get the cost or fairly closely on the project to do 1,000 feet. That's parametric estimating. 3-point estimating is usually done with from a bottom up point of view, but it could be done from top down. I'm going to talk about 3-point estimating because that ties into the methodology that I use. And this basically uses 3 different points in which you can create your estimates from. Let's talk about that 3-point estimating. First of all, there's an optimistic point of view, a pessimistic point of view, and a most likely point of view. I'll talk about this the way that I normally approach this. If I talk to a team member that is going to provide, again, I'm thinking about from a bottom up point of view. We've detailed out the plan. We know all the tasks. Then what I want to do is to be able to finalize that project plan that I'm putting together. I'm going to do a bottom up point of view. I'm going to talk to each individual that is assigned to do those tasks as best I can. And the way I approach that discussion with that individual to give me I make sure that they understand the task that is necessary to complete. And I'm going to ask them to think about the task in 3 different ways. First of all, if they were to work on that task and they completed, if they had no interruptions from them, if they had the ability to start the task, work on it without any interruptions, got to the end of it, and were able to complete it without having to be pulled off and doing anything else, nothing went wrong, how long would it take, or what is the work effort that it would take to complete that task? And I say work, not the duration. I'm asking how many hours will it take for them to complete that task, assuming everything goes well. And will usually get an estimated hours on that. Then I tell them, okay, think about what if a whole bunch of things went wrong? If you did the same thing, you had that same task, how long would it take me what is the effort that it would take to complete that task? If I got interrupted a lot, or if there were maybe some technical problems, maybe you had to redo some stuff. What would be the worst case that it might take effort-wise? Again, I'm always asking them to think about it from a work point of view, not for a duration point of view. And then the last question is what's the most likely? Knowing that not everything works perfectly, there might be some interruptions, but more of a realistic expectation of what's going to happen to complete that. There might be some interruptions. I might not be able to work on it full time. I might only be able to work on this task because I have other tasks half time, so there's some context switching, that type of thing. What's the most likely effort? So when I get those numbers, then I apply them. There's 2 different ways that you can calculate these. There's the triangular distribution, and the way this works is to get the estimate, you take basically the average of the optimistic, the most likely, and the pessimistic. So you take those 3 numbers, add them together, divide by 3, and gives you the average for an estimate that will come up. And you can use that for your estimate for that task. The beta distribution method is very similar. However, what you're doing is you're giving more weight to the most likely. So you take the optimistic and the pessimistic, you add those together, and then you add 4 times the most likely, giving it more weight, dividing by 6, and then you get an average with a heavy weight on the most likely. And that's the estimate that you can use. So that's the 3-point estimating technique. Now, I've developed an approach that is a little bit different. I take the 3-point estimation technique and modified it a little bit and combine that with a critical chain method. Now, what is the critical chain method? This is actually in the PMBOK, the version 5 of the PMBOK. I'm not exactly sure when they added it. I've been using the critical chain method for several years, and originally it wasn't in PMBOK, but it's been added. But the way that the critical chain method works when you're developing a plan is there's the concept of feeding buffers and project buffers. The buffers are used to provide padding for those things that are um, along the lines of the known unknowns. Though you know that their estimations might be off, you know that things might happen, it provides a means in which you can apply a buffer in your plan so that you can account for those things that are unknown, known unknowns. Now, the way that this would work is, so for instance, if I have in this view, you see that there's all these different tasks. There's 6 different tasks, and the feeding buffers are put in there in case, in the paths of, in this case they're showing in the non-critical path. You could actually put them, I've also used them in the critical path as well. But what happens is you just take those feeds and put them in there, and then the project buffer is also another way to say, okay, to give in the critical path an additional length of the buffer. So now let me show you how I apply this in the method I've put together. Excuse me. So what I do is I will take that 3-point estimation methodology and I apply it a little bit differently. I'll take the most likely effort that is identified by the team member that I'm working with, and I'll apply that to the activity. So if the individual gave me an most likely of 75 hours to do a task, and the optimistic was 50 hours, and the pessimistic was 100 hours. I would take the 75 hours and put that into each one of these activities and apply that in my project plan for what I'm actually going to plan for. And then what I'll do for the feeding buffers is I'm going to take the difference of between the most likely and the pessimistic view for each activity, add those up for the chain that I'm working on, and add that as the feeding buffer. So for instance, in this instance that I just mentioned, if I had a most likely of 75 hours for both of these activities, and my pessimistic for both of these activities was 100 hours, I would take the difference between the 100 and the 75 for 25 hours for each one of these activities, for activity A and activity B. I would add those together, 25 plus 25, 50 hours, and I will put that 50 hours into the feeding buffer. Now, you might think, all right, well, that you're just building fluff into it. Well, yes and no. I am building fluff into it, but I'm accounting for the fact that I know that there are known unknowns out there. There are things that are going to be happening. And so you can apply those to the feeding buffers. The other thing you can do is, as you identify your risks, you can take those risks, whatever value you assign to those risks, and put those into your project buffer. You can also apply them into your feeder buffer as well. So this is a method in which I've used to apply buffers in the project based on the estimations that I've been given. Now, you might say, well, this is just going to elongate your project. It can, but what I think is the most important part of this is, first of all, everybody needs to understand that these buffers are in there. The goal is to not use these buffers. But when you share information about when the project is going to be delivered, the timing, you always assume that the buffers are going to be used up because much of it will. But you're going to drive the team to deliver on their most likely estimates. So I'm always going to hold the team to that most likely estimate. And so what happens is, if a task is, the team member is going to be working towards completing it on their most likely effort. If they get to the point where they're 40 hours into that activity and it's going to take them another 10 hours, then they're going to be hitting my most likely. If they get to that 40 hours and they realize, oh, because of these things that have happened, I'm going to have to take 20 more hours. That means I'm going to overshoot my estimate by 10 hours. Well, remember, I've accounted for that in my feeding buffer. So I can actually take out, I've started to use that feeding buffer. Remember, there's 50 hours in there. So if I finish that whole set of activities A and B, and I've only used up 10 of that feeding buffer, I've gained myself 40 hours of effort that I've accounted for, but so will help me keep in budget and on time. But I've been able to control that. So what happens is you watch your activities, and then you also watch the feeding buffers. And if you're controlling and watching those feeding buffers, that will help you keep on track. And you could also have those discussions to find out if the individual knows that they can't go over their most likely estimate without having a discussion with the project manager. Then you are actually having a discussion on each one of these activities, uh, especially when you're talking about the ones that are going into those feeding buffers, so you can track those. So this is a proven method that I've used to be able to help provide a better way of building my plan, using the estimates, and helping my team through that estimation. So remember that those estimations are really important. It provides the predictability and stability of your project. And this is just a proposed method that I have found very effective that you can use. So I just wanted to share those thoughts with you. Let me go back here, turn my sharing off. So hopefully that was helpful for you. And I am sorry we did have a little bit of hiccup getting started on this, but hopefully that was helpful, and you've gained some information. I wasn't able to get to any of the questions because of the technical problem at first, and we're running out of time, so I just wanted to make sure we end on the top of the hour. But if you have questions, I will be posting this at sensiblepm.com/hangout. And there, when I post that, I should get that up in the next couple of days. You should be able to go there if you have questions or thoughts about this method in which I shared. I welcome you to leave comments there. Tell me what you think. Tell me if that works for you, if you have any other suggestions on helping improve estimations for your team. Absolutely worthwhile. I might mention one of the things that I specifically kept out of this is the whole Agile or Scrum method in estimating. I think that is a great thing. Scrum is a completely different approach. I didn't have time in this presentation to really talk about that, but I think that is something that the approach that Agile takes in working through estimations is a very valuable thing, and we probably will have in future Hangouts some discussions about that specifically. So there you go. Again, apologize for the the issue we had getting started, but hopefully that was good information. And I hope you have a great day, and talk to you later. Hangout, the Sensible Project Manager Hangout is signing off. Have a great day.